Welcome, Hornets, and thank you for joining me today. I'm working on classwork number 8, and I'll be doing the even problems 2, 4, 6, 8, 10, and 12. In fact, I'll probably be doing numbers 2, 4, then I'm going to be doing number 8, and then I'm going to finish with number 12. I will not be doing number 6, as it is very similar to number 4, and I will not be doing number 10. It is very similar to number 3, or pardon, number 2. All right, so just be aware we're looking at numbers 2, 4, 8, and 10 being done in this video. For those of you who are not students of mine, I'd like to give you a moment to take a screenshot so that you can follow along. Let me give you just a minute. Alrighty, now that you've had the opportunity to take a screenshot, please be aware that problems such as number 2, which are working with transcendental functions, we're going to be using a calculator for, although it can be done by hand. I think it's important that you are able to do both. So let's go to y equals. We're going to turn it on, go to y equals, and clear everything off. And I've got other problems that are here, so we're just kind of cleaning things up. Now, there are multiple ways in which we can do this on our calculator, but I recommend that you start by simply putting in the fraction 1 over cosine x. And you'll notice I have to use the reciprocal function for this in order to get that secant. Then put the negative 2 cosine of x, and please make sure that you are in radian mode. Once you've got that, you need to go to your windows, and we're going to be using 0 to pi divided by 4. Now, just because you've got your windows for the x doesn't mean you have the windows for the y. So what I recommend is that you hit zoom fit and then rearrange the graph as needed. Now you'll notice right down here we don't see the entire graph clearly, so I'm going to go back to my windows and I'm going to make sure that my y goes down to negative 3 and goes up to positive 3. I can now see both curves as they exist very clearly. We can also see that the secant is on top and the minus 2 cosine x is on the bottom. As a result, we're going to be working with the upper minus the lower orientation according to our endpoint. So we're going to go 0 to pi over 4, and we're going to have our upper orientation, which is the secant squared x minus the negative 2 cosine x dx. Now the first option is to put this into our calculator. So we're going to go to our home screen, we're going to hit math 9, and we're going from 0 to pi divided by 4. And because our first equation was the secant, I'm going to do alpha trace y1 minus alpha trace y2 dx. We hit enter, and we get our answer, 2.414. Now, the other option that we have is to go to your graph. Now, this is going to require that you write information down as you do each area under the curve. So we're going to start by finding the second trace. That's 7, the integration. And we're going from 0 to pi over 4. And we hit enter. And it's going to add up all of that area. And we want to write that number down, 1. So we're going to add 1 to whatever we get for our second area. Now remember, it's currently a negative, and we want our area to be positive. So we're subtracting that area. So whatever we get, we're going to make it a double negative and add the 1 to it. Okay, here we go. Second trace, we're doing 7 again. This time we're using our red equation, that's the second. We hit the arrow down. 0 is our lower limit. Pi divided by 4 is our upper limit. And you'll notice we're getting negative 1.4142. We're going to make that a positive 1.414. And then we're going to add 1 to it, and it will once again get us back to that 2.414 that we saw on our integration. Now, another option is to turn off both of these equations and put it in as a whole. the alpha trace of y1 minus the alpha trace of y2. And once again, it's same windows, but we want zoom fit because it's going to alter the graph. Because we've combined it, we're going to see just a single graph. All right, we need to see the x-axis, so we're going to change our windows, and we're going to make sure that we go down to -1 so that we can see it clearly. There's our graph. We can see the x-axis. We're going to do second trace 7, and our lower limit is 0. Our upper limit is pi divided by 4. And when we hit enter, it's now going to add all of that up, and we will see that we get 2.414 again. And there it is, 2.4142. Now, the third option that we have is that we have to do this by hand. And unfortunately, you have to be prepared for that. Oftentimes, teachers will require both calculator and no calculator, and I know that that is the case for the AP test. So we're going to separate it into its two parts. Secant squared x dx minus the double negative for the 2 integration, cosine goes here, and we're going from 0 to pi over 4. Now this piece is going to come out as tangent x, 0 to pi over 4, plus, and we now have 2 sine x, 0 to pi over 4. When we plug in the pi over 4, we get 1. When we plug in the pi over 4 into sine, we get 2 times root 2 over 2. That's going to give us 1 plus root 2, and that is 2.4142. So here it is as an exact value, here it is as the decimal, and we've now seen 3 different ways to do it. Let's go ahead and take a look at number 4 now. Number 4. Once again, we want to go to our y equals, and we're going to put this into our calculator. Here we go. I have negative alpha y equals for my fraction, and I'm going to put 4 divided by x squared, and then I have my y2. I'm now going to go ahead and do the interval 1 to 2. And I want to do, let's try that again. Let's do our 6 and 1 to 2. There we go. And now I'm going to go ahead and I'm going to hit, what would that be? Zoom fit. We're going to have to rearrange our graph again because you'll notice we don't see that 2 very clearly. So I'm going to go ahead and I'm going to make sure that my windows are large enough to see the entire graph. Now we can see the entire graph. If we're using our calculator, we find the area of this portion, and then we subtract the area of this portion. It's going to give us a double negative to make a positive. Working on the home screen, we're working with Math 9 from 1 to 2. Once again, we have our upper minus lower, but this time our upper equation was the y2, and our lower equation is the y1. Now when we hit enter, we get a total of 4. Let's go ahead and go to our graph, make sure that we can see that. Let's do our second trace, integration 7 from 1 to 2, enter. Now remember, this is the minus, and so I'm going to make this a negative 2, and it's going to become a positive 2. Let me make sure you see that. So here we did that integral. Let me just go ahead and do it again, just to make sure. We have our graph. We're doing our second trace, 7, for our first equation from 1 to 2. It's going to give us the area, but because it's below the x-axis, it's representing a negative area. We want to make sure that we go minus that negative area. So that's why we end up with a positive 2. We now go and repeat the same process, but this time we click our arrow down to get to the red. We have our lower limit is 1, upper limit is 2. It finds the area as 2, and 2 plus 2 makes 4. Let's now go ahead and take a look at it, this time working with our hard copy, old school, and we're doing 1 to 2. We have our upper equation, which was 2, minus the lower equation, negative 4 over x squared, dx. I'm going to separate it so that I can do it in the two different ways. Now, if you feel you can do it all at once, you can go right ahead. It does go quite nicely. I just like to avoid some of the confusion that occurs. And this is from 1 to 2. So we're putting in the 2, and we end up with a 4 minus 2 minus 2 minus 4. This gives me 2 minus, that's the area of negative 2 that we saw, and the double negative makes it a positive, so we end up with 4. And thus 4 is our area. Alrighty, we're going to be going to number 8 next. Once again, number 6 is pretty much identical to number 4, so you shouldn't have too much of a problem. Number 8 is a little bit more confusing. The reason it's more confusing is because you'll notice they don't give us endpoints. In fact, what we're looking for are the intersections. So we're going to put our first equation, and please make sure you write it carefully. I have in the past written this very wrong. So please make sure that you write the equation correctly, or you will have a problem. And then under my y, I'm going to make sure I put x. And our goal is to now find the intersection. So I'm going to do zoom 6, because I have no idea where the intersections are. And as we look at our graph, you'll notice negative 2, 0, and 4 are our endpoints. So we're going to need to just make sure about that. So I'm going to do second trace, find my intersection 5, and move closer to it so that I can go enter, 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 and I find that it is indeed negative 2. I'm then going to do and repeat the same process, finding the intersection. We already know we have the 0, 0, so I'm not going to bother with that one. And you'll notice the second intersection is 4. That means that we have two orientations. Notice that at 0, they flip, so that what was our upper becomes our lower, and what was our lower becomes our upper. So we're going to have the blue minus the red from negative 2 to 0, and then we're going to do red minus blue from 0 to 4. Here we go. Negative 2 to 0, and we have our blue up top. That's going to be x cubed over 2 minus x squared minus 3x minus x dx, and we're going to add to it 0 to 4. Now we flip the orientation, it becomes x minus x cubed over 2 minus x squared minus 3x dx. Now this is what we're going to want to put into our calculator. So let's go ahead and just take care of that. So as we put it in, let's make sure you can see what I'm going to put into the calculator. And here we go. Math 9 from negative 2 up to 0. And we have y1 minus y2 dx plus math 9 from 0 up to 4. And now because the orientation has changed, we have to now do y2 minus y1. dx, and we hit enter. And you'll notice we get 24 and 2/3. So 24 and 2/3 is the area we're trying to locate. Let's now go ahead and see what happens on this one. So if I do my graph, please take note that I've got two different orientations. If I'm going to do the integration under my y equals, I'm going to have two distinctly different ones. So let's go ahead and get rid of this and this. And we're going to start with the first piece. Now, keep in mind that this is my upper minus my lower, and this is from the -2 to 0. So we do graph, zoom fit. This is still -10 to 10. And I'm now going to want to make sure that I clean up my windows. And we're going to need to make sure that we have our -2 to 0. Now we can graph it. And it's pretty hard to see, so let's just do a zoom fit. Should make this a little bit easier for us to work with. Notice that that graph with zoom fit became very clean. Now we do second trace, intersection 7. We're going from our value of -2 to our value of 0. It's going to add it all up. We're going to want to write this value down. So we get 3 and 1/3. Now, having that 3 and 1/3, we're going to have to go back to the next graph. This time, we need to have y2 minus y1. Now, when we graph this, once again, hit zoom fit. I forgot to put 0 to 4, so give it a moment. We're going to have to change it. Here we go. Windows, 0 to 4, and now zoom fit. Again, it's giving us a very nice graph. And now we can do second trace, 7, and we're going from the 0 to 4. It's going to find our area, and we're going to add it to 3 and 1/3. We get 21 and 1/3. So 3 and 1/3 plus 21 and 1/3 is 24 and 2/3, which was the answer we had before. So let's go ahead and now take a look at how we're going to do this by hand. If we're working by hand, I recommend that you do each piece one at a time. So -2 to 0, I'm going to put this as x cubed over 2 minus x squared minus 3x minus x. And this is giving me the integration -2 to 0 of x cubed over 2 minus x squared minus 4x dx. For the second piece, going from 0 to 4, we're now going to have that x. Now, because it has that minus in it, okay, let's just remind ourselves. That minus is going to have to distribute, so I'm going to have a 4x plus x squared minus x cubed over 2 when I distribute and add like terms. That's a 4x plus x squared minus x cubed over 2 dx. Now, these are the two pieces that I'm going to want to integrate. 1/2 times 1/4 x to the 4th minus 1/3 x cubed minus 4 over 2 x squared from -2 to 0. The 0 is going to cause all of this to cancel. But the -2 is going to give me a value. So I'm going to have 1/8 of -2 to the 4th, which is 16, minus 1/3 times -8. And then I have this minus 2 times -2 squared, or positive 4. This is giving me 2 plus 8/3, and then I have 4 minus 8. And this is giving me negative 2 plus, let's do minus 6 plus 8/3. And this is going to give me a negative 3 and 2/3, 3 and 1/3, excuse me. And that is the positive 3 and 1/3 that we got before. Okay? So now we're going to go to this piece. This piece is now plus 4 over 2x squared plus 1/3 x cubed minus 1/2 times 1/4 x to the 4th, and this is going from 0 to 4. Now when we plug in the 0, we're not going to subtract anything. So all we have to do is add. We have 2 times 4 squared, which is 16, plus 64/3 minus 256 divided by 8. This is giving me 32 plus 64/3 minus 32 for a sum total of plus 64/3. And that's going to give me 21 and 1/3. That'll allow me to now add these together. And when I add the two values together, 3 and 1/3 plus 21 and 1/3 equals the 24 and 2/3, which we got as our answer before. Now the last problem that we're doing today is number 12. Let's just take a quick look at number 12. Once again, we're going to put this into our calculator. Y equals, I'm going to just clear all of that out, so I just start fresh. We have negative alpha y equals, to get the fraction, x cubed. Let's try that again. That was x cubed over 2. And I'm just trying to put this into my calculator right now. Don't forget your plus 3, x. Then in y2, I have negative alpha y equals, to get the fraction, and I'm looking at x squared divided by 2. Once again, we have no idea where the intersections are, so we're going to need to just do a zoom 6. It's going to give us a great big graph, and we're just going to have to deal with it. All righty. We have an intersection at 0, 0. That's the easy one to find. We think it might be around negative 2, and this one around 3. Let's find out. Second trace, find the intersection 5. Get close to what we want to find the intersection of, and you'll notice we get negative 2. Now we go to the other, second trace, find the intersection. Once again, get close to it. Enter, enter, enter. And you'll notice we get positive 3. So our y1 is on the bottom. So as we set this up, we're looking at the integration, and we're looking at negative 2 to 0. And we have our first equation, negative x squared over 2 minus negative x cubed over 2 plus 3x dx. And then we're going to add to it the integration from 0 up to 3. And now we flip the orientation. So we now have negative x cubed over 2 plus 3x. And we're subtracting the negative x squared over 2, which will give us a double negative. Okay? You can't really see that, so let me try to show it to you. And then we've got that dx. So we're going to put this into our calculator exactly as we see it. Go to the home screen. We're looking at Math 9. We're going from negative 2 up to 0. We're going to put in our y2 minus y1 dx. Then we're going to add Math 9 from 0 up to 3. we're going to put in alpha trace y1 minus alpha trace y2 dx and hit enter. We get 10.54166. So we're obviously going to get a fairly ugly fraction when we try to do this by hand. Let's go ahead and do it by hand, please. So we're going to put this down entirely as we see it onto our piece of paper, and then we're going to go through one piece at a time. The integration from -2 to 0. And we have this negative x squared over 2. We have a plus x cubed over 2. And we have a minus 3x. Notice how we have to make sure we change all of the signs and add like terms. For this one, we're just going to go ahead and start with the 3x plus x squared over 2 minus x cubed over 2 dx. And this is from 0 to 3. We can now go ahead and begin. Here we go. When we integrate, we're looking at negative 1/2 times 1/3 x cubed. We have plus 1/2 times 1/4 x to the 4th minus 3/2 x squared. And this is from -2 to 0. The 0 causes everything to cancel, and we're going to then subtract. We have -1/6. The -2 makes it a positive, and it's multiplied by 8. We have plus 1/8 times 16 minus 3/2 times 4. This is giving me, 4/3. We are adding to it a positive 2. And then we have a minus 6. This is giving me minus 4/3 minus 4. That's going to give me a minus. And when I take that 1 away, I'm at 3. When I take another 1/3, I'm at 2 and 2/3. And it's a negative, and the double negative applies to be 2 plus 2 and 2/3. We now go to the second part of the problem. Once again, we're just integrating, so I have 3/2 x squared plus 1/2 times 1/3 x cubed minus 1/2 times 1/4 x to the 4th, and we're looking at 0 to 3. Once again, the 0 is going to cause that to go away, so we are simply adding, and we have 27/2. We then have 27 divided by 3 is 9/2. And then we have minus 81/8. We're going to need to slowly add this together. This is 36/2 minus 10 and 1/8. That's where that ugly fraction is coming from. This is giving us 18 minus 10 and 1/8. This is giving me 8, 7 and 7/8, which I need to add. Now I'm just going to go ahead and add it with my calculator and compare it with the 10.54166. 2. Let's just do 2 plus, 2 divided by 3 plus, 7 plus, 7 divided by 8, enter. And you'll notice we get the 10.541666. And that is classwork number 8. I hope this has helped. Please put a like if you feel that this was valuable and that this was useful. If not, please put comments on how I can improve. Thank you very much, Hornets. Please be safe, take care, and thank you for watching. Bye-bye.